Ever wonder how your phone just knows that New York is one single place, not just two random words? Well, the secret sauce, or at least a big part of it, is a really cool tool called Conditional Random Fields, or CRFs for short. They're basically what help computers see the hidden grammar and structure in our language. So yeah, let's dive in and see how it all works.
All right, so here's the game plan. We're going to start with the big challenge that CRFs are built to solve. Then we'll see why they're such a smart upgrade from older models. After that, we'll get into how they actually learn context, check out where they're used in the real world, and wrap up with a look at their pretty surprising team-up with modern AI.
Okay, so first things first. Before we can really get why CRFs are so cool, we've got to understand the problem they were born to solve. And that is the sequence labeling challenge. You know, at its heart, sequence labeling is exactly what it sounds like. You take a sequence of things, like words in a sentence, and you stick a label on each one. So take the phrase, John lives in New York. We, as humans, instantly see New York as a single location. But teaching a computer to see that connection, to realize it's one thing and not just two separate words, well, that's the real trick, isn't it?
And this is where it gets really interesting, because the same sentence can mean different things depending on what you're looking for. Check this out. On the left, you've got part of speech tagging. This is all about grammar, right? It labels John as a proper noun. But on the right, you have named entity recognition, or NER. It's focused on meaning. It sees John as a person, and crucially, New York as a single location. Same words, different goals.
So the big question is, how do you build a model that can actually handle this kind of complexity? This is exactly where Conditional Random Fields, or CRFs, come into play. They are a way smarter approach, a big leap forward from the older methods.
Okay, so the older models, things like hidden Markov models, they kind of had a tough time. They tried to figure out the probability of both the words and the labels showing up together, but they had this major weakness. They had to assume every word was independent, which, in language, that's just not how it works, right? Words depend on each other. CRFs made this one brilliant change. Instead of asking about everything together, they ask a more direct question. Given these specific words, what's the most likely sequence of labels? This simple shift makes them so much more flexible and powerful.
And that one change, it gives CRFs these three huge advantages. First, they're super flexible. They can use all sorts of different clues from a sentence, even if those clues overlap. Second, they're context-aware. They get that the label for one word totally affects the label for the next. And third, they stay laser-focused on the real job, just predicting the best string of labels for the words you give it.
Okay, that all sounds great in theory, but how does a CRF actually do all that? How does it learn? Well, instead of diving into a bunch of scary math, let's just think of a CRF as a detective. Its job is to look at a sentence and solve the mystery of the correct label sequence, using all the clues and evidence it can find.
So what's the detective's main tool? It's something called a feature function. Don't let the name scare you. Just think of it as a simple clue. For instance, a classic clue for finding a name is capitalization. So a feature function could just be a little rule that says, hey, heads up, if this word starts with a capital letter, there's a pretty good chance it's a name or a place. And the detective's process here is super logical. Step 1, it makes a big list of all the potential clues it can look for. Things like capitalization or maybe words that end in ing, you get the idea. Step 2, it learns how important each clue is by looking at thousands and thousands of examples that have already been labeled correctly. Then step 3, for a brand new sentence, it calculates a score for every single possible label sequence based on those clues and how important they are. And finally, step 4, it just picks the one sequence that gets the highest score. That's its prediction.
This whole detective-like process has made CRFs incredibly useful in the real world. Let's take a quick look at where this powerful tool is hiding in plain sight, probably in things you use every single day.
And seriously, they are everywhere. We've already talked about the obvious ones like finding names and figuring out grammar in text. But CRFs are also clutch in really specific fields like biomedical research, where they help scientists sift through mountains of papers to find mentions of genes and proteins. They're also used to chop up sentences into basic phrases, and even to help computers read handwriting from old scanned documents. Pretty versatile, right?
All right, so at this point, you might be thinking, okay, I get it, but what about all the modern AI? BERT, GPT, all these giant language models. Haven't they just made CRFs obsolete? And that is an excellent question. The answer, though, is really surprising. It's all about teamwork.
So yeah, let's just ask it straight up. In today's world of massive neural networks, is there still a place for these more structured, almost rule-based models?
And the answer is a huge no. They're not obsolete, not even close. In fact, they've teamed up to form one of the most effective partnerships in modern AI. We're talking about the BERT plus CRF power duo.
So here is how this dream team works. Think of BERT as this incredibly smart reader. It's the feature extractor. It goes through a sentence and develops this deep, rich, contextual understanding of every single word. Then it passes all that amazing insight over to the CRF. And the CRF's job? It's the final logic check. It's the consistency expert. So for example, BERT might know that New and York are both part of a location, but it might mess up and label both as the start of a location. That doesn't make sense. The CRF steps in and enforces the structure, the rules. It makes sure that a start of a location tag is followed by an inside location tag. It's the perfect marriage of deep understanding and logical structure.
And this whole thing brings us to a really fascinating final thought. This partnership, right, between the almost free-form, intuitive understanding of a model like BERT and the rigid, logical constraints of a CRF, it works unbelievably well. And it really makes you wonder, doesn't it? As we keep pushing AI to reason more and more like a human, what role will these structured rules and logical guardrails play? How important will they be in building systems that are not just powerful, but truly intelligent?